Hello, chemistry students. Here are your corrections for the homework assignment from page 211, questions 9 through 12. Number 9 says, write word equations for the following chemical reactions. Letter A, pure copper can be produced by heating copper 2 sulfide in the presence of diatomic oxygen from the air. Sulfur dioxide gas is also produced in this reaction. So our word equation, remember, our only symbols are going to be arrows and plus signs. So pure copper can be produced. Here's one of those tricky ones because pure copper is actually a product. Okay. By heating, so we can put that little heat symbol if we want there. Copper 2 sulfide, so that's a reactant. In the presence of diatomic oxygen, so I'm going to kind of do a plus oxygen. Sometimes my iPad is not wide enough. Okay. Again, diatomic is extra information I don't need. From the air is extra information I don't need. Okay. Sulfur dioxide gas is also produced in this reaction. So my other product here is sulfur dioxide. And again, the gas part of that is extra information that I don't need. So that's A. Letter B, water is formed by the explosive reaction between hydrogen gas and oxygen gas. So again, here's my arrow. Water is formed. Formed, that means water is a product. By the explosive reaction, extra formation, between hydrogen gas and oxygen gas. So this is hydrogen. Again, gas is extra formation I don't need. Plus oxygen. Letter C. When baking soda, sodium hydrogen carbonate, is heated, it decomposes, forming the product sodium carbonate, carbon dioxide, and water. So, again, here is my arrow. When baking soda, which is sodium hydrogen carbonate, and I'm going to use the science or the chemistry term for it, is heated. So again, I can put that arrow or that triangle if I want over my arrow. So it is heated. So that's the reactant. So sodium hydrogen carbonate. That's one compound. Okay. Is heated. It decomposes, forming the product. So sodium carbonate is one of my products. Carbon dioxide, so plus carbon dioxide. And water, so plus water. So that is my word equation for this one. Number 10, balance the following equations. So letter A, we have sulfur dioxide reacting with oxygen to produce sulfur trioxide. So I have one sulfur, 2, 4 oxygens, and 3 oxygens. So I'm going to try to make them 6 because I'm going to have an even number. So to get an even number, I'm going to put a coefficient of 2 in front of sulfur trioxide. Now that's also changed my sulfur, so I'm going to go ahead and put a 2 in front of sulfur dioxide. So now, kind of checking to see where I'm at, I have 2 sulfurs, 2 sulfurs. 2 times 2 is 4, plus 2 more is 6 oxygens. 2 times 3 is 6 oxygens, so that is balanced. Letter B. We have iron 3 oxide reacting with hydrogen to produce iron and water. So, 2 irons, 1 iron, a coefficient of 2 in front of iron. 3 oxygens, 1 oxygen, a coefficient of 3 in front of water. 3 times 2, 6 hydrogens, a coefficient of 3 in front of hydrogen gives me 6. I'm going to check it. 2 irons, 2 irons, 3 oxygen, 3 oxygen, 3 times 2 is 6 hydrogens, 3 times 2 is 6 hydrogens. This is properly balanced now. Letter C, P phosphorus plus oxygen yields tetraphosphorus decoxide, P4O10. One phosphorus, 4 phosphorus, I need a coefficient of 4 in front of phosphorus. 2 oxygens, I have 10 here, so I need a coefficient of 5 in front of oxygen. I think I'm balanced, I'm going to check. 4 phosphorus, 4 phosphorus. 5 times 2 is 10 oxygen, 10 oxygen. This is now properly balanced. And letter D, aluminum reacts with nitrogen to produce aluminum nitride. One aluminum, 2 nitrogens, 1 nitrogen, so I need a coefficient of 2 in front of aluminum nitride, which means I need a coefficient of 2 in front of aluminum. I think I'm balanced. 2 aluminum, 2 aluminum, 2 nitrogens, 2 nitrogens. Yep, we're balanced. Number 11. Write formulas and other symbols for these substances. Letter A, sulfur trioxide gas. So sulfur trioxide is a molecular compound, so my prefixes become my subscripts. So it's SO3, and the gas is a subscript of a G. Potassium nitrate dissolved in water. Dissolved in water is talking about it being an aqueous solution. Potassium nitrate is an ionic compound, so I'm going to write symbols, charges, crisscross, make sure it's the lowest whole number ratio. My symbol for potassium is K. It has a charge of +1. Nitrate is NO3, charge of -1, so it's just going to be KNO3. And it's dissolved in water means I'm going to put an AQ behind it. Okay. Letter C, we have heat supplied in a chemical reaction. There's 2 different ways that I can indicate that I have heat. I could put the triangle over my arrow, or I could just write the word heat over my arrow. Either works. Letter D, metallic copper. Copper is Cu, and the fact that it's metallic means that it is a solid. Letter E, liquid mercury. Mercury is Hg. And to show that it's a liquid, it's the subscript of an L. And letter F, zinc chloride as a catalyst. Catalysts get written over an arrow because they're not part of the reactants or the products. Zinc chloride is an ionic compound, so I'm going to write symbols, I'm going to write charges, I'm going to crisscross, I'll make sure it's the lowest whole number ratio. Zinc is on your helper sheet. It only has one possible charge of +2. Chloride is Cl, so ZnCl2, so it kind of would look more like ZnCl2 written over my arrow. Number 12, how is the law of conservation of mass related to the balancing of a chemical equation? Remember, our law of conservation of mass says that mass can't be created or destroyed. What that means is that we can't have atoms, can't be created or destroyed, because atoms maintain their mass, so we can't create or destroy atoms, or we would create and destroy mass. Therefore, you're going to be atom counters. And make sure you have equal numbers of all atoms on both sides of your equation. Again, your textbook said, when balancing an equation, the number and kinds of atoms in the reactants equals those in the products. Thus, atoms and mass are conserved. So that is that homework assignment. I hope if you were having some questions or problems with it, that helped. Have a great day.